Hi, welcome back to the Chemical Reactions unit in Science 1206. I'm Miss Ledwell, and in this video, we'll talk about some of the factors that affect the rate of chemical reactions. Specifically, we'll address concentration and catalysts. So let's get started. What are the factors that affect the rate of chemical reactions? We'll discuss four. They are temperature, surface area, concentration, and the presence of a catalyst. In our last video, we focused on temperature and surface area. In this video, we will focus on concentration and catalysts. First, let's review the concept of concentration. You learned about this in grade 7 science. Concentration is defined as the quantity of solute that is dissolved in a certain quantity of solvent. A solution can be described as concentrated if it contains a large amount of dissolved solute for a certain quantity of solvent. A solution is dilute if it has a small amount of dissolved solute for a certain quantity of solvent. Let's look at these two examples. The first example is a dilute solution. It has a small amount of solute dissolved in the solvent. The second one, the darker green, is a concentrated solution. This one has a large amount of solute dissolved in the same amount of solvent. The higher the concentration of a chemical reactant, the more reactant molecules are available to react in a given volume. With more reactants available to react, the faster the reaction is. Imagine a room full of people. The more people there are, the more likely you will bump into someone. It's similar to concentration in a reaction. The more concentrated a substance is, the more particles available to bump into each other, and there is a higher chance of collisions, making the reaction go faster. Consider the reaction between hydrochloric acid and zinc metal. The reaction looks like this. So we have zinc metal added to hydrochloric acid, and we'll get the production of hydrogen gas and zinc chloride. Here you can see we have two beakers containing the hydrochloric acid. The first beaker is more concentrated hydrochloric acid than the second beaker. Both beakers are having 2 grams of zinc added to them. 4 observations were made of the beakers over a certain time period. If we look at time 1, 2, and 3, we'll notice that in the more concentrated hydrochloric acid, the reaction is going faster. We can see that the zinc is beginning to disappear at time 2 and is completely gone at time 3 in the more concentrated hydrochloric acid. In the less concentrated hydrochloric acid, it takes a longer time for the reaction to occur. Next, let's look at the effect of a catalyst on reaction rate. A catalyst is a substance that speeds up a chemical reaction without being used up or chemically changed by the reaction. In other words, the mass of a catalyst is the same before and after a reaction occurs. Catalysts work by providing an alternate pathway for a reaction that requires less energy. This means more reactions happen in a given time because the particles don't need as much energy to react. In this graph, the green line shows the reaction without a catalyst, and the red dotted line shows the reaction with a catalyst. With the catalyst, the activation energy is lowered, and the reaction occurs quicker than without the catalyst. Let's look at some examples of catalysts. Your body contains enzymes, which are nature's catalysts. Enzymes speed up biochemical reactions that are essential for life. For example, saliva contains an enzyme called amylase, which speeds up the breaking down of starch molecules. Like in this example, the saliva on the puppy's tongue is going to speed up the digestion of his cookies. In industry, catalysts are used to speed up chemical processes, such as producing fertilizers and plastics. Catalysts can significantly reduce the energy required for industrial processes, saving money and reducing environmental impact. Now let's briefly pause this video and watch the video Factors Affecting the Rate of Reaction, which is embedded in Brightspace. When you're done, return here and resume this instructional video. Now let's do a little review of reaction rate. As each factor is unveiled, think to yourself, does this speed up or slow down the reaction rate? and then we'll go over the answers. Our first factor is if you raise the temperature. What do you think will happen to the reaction rate? Raising the temperature speeds up the reaction rate because the particles move faster. How about decreasing the temperature? Decreasing the temperature will slow down the reaction rate because the particles are moving more slowly. How about grinding the reactant into a powder? This is going to speed up the reaction rate because we've increased the surface area available to react. What does adding a catalyst do? Adding a catalyst speeds up the reaction rate. How does decreasing the concentration affect reaction rate? It will slow it down. What about increasing the concentration? That's going to speed up the reaction rate. How about decreasing the surface area? That will slow down the reaction rate. Adding heat is going to speed up the reaction rate. Diluting the reactant will slow down the reaction rate. And removing heat is the same as reducing the temperature. That's going to slow down the reaction rate. That's the end of our lesson, so now it's time to review. Please complete the learning activities in Brightspace.